Okay, so one of the things you're going to have to decide, and it's not an easy decision, is this triangle right here, is this triangle obtuse or acute? Okay, so let's kind of take a look at it separately. So here's A, B, C, this is 45, okay? And I know this is 40. If it's a right triangle, so think with me. If it's a right triangle, let's pretend, what should this angle be? 45, right? Okay. When you did the work, the person that did the work on the board to find side C is 42. If this was a right triangle, what should this be? Okay, but it's not, right? The actual value we got is 42.496 for the person that did it on the board. 42.496. So I want you to think about that. The actual side here, that's through law of cosines, yeah? Because this was 60. So decide, is it acute or obtuse? So this should be 40, but it's longer. So think about it like this. Yeah, it's obtuse. Here's the reason, right? If this was 40 and this was 40, it would form a right angle, and this is fixed to be 60, right? But because this side is longer, it actually has to lean a little bit that way in order for the 60 to match up. Does that make sense? So this is actually obtuse. That's going to affect your answers. Okay? This is actually obtuse. That's going to affect your answers. Why? Because for part B, right, the human that found that distance from the center of the pitcher's mound to second base, so this distance here, okay, which I'll just call D, they found that to be 39.935, and they use units. That's excellent. D. Okay. Is that correct? So let's see, they set it up, they said sine of 45 over, okay, I think they saw this angle as 45, so they said sine of 45 over C, right, over this, which was found up above, is equal to sine of 41 point, so they found this side, okay? So I'm just asking if it's correct. Anyone have any opinion either way? So, wait, I'm talking about this though. Oh, what are we talking about?
Yeah, because that angle, or part B is like 180 minus.
So the 93 is on. Yeah. Another approach to this problem, to part B though. Anyone see it? Some of you asked a question that I thought was leading towards that. Anyone see another approach? You should look at the whole triangle, right? That whole triangle is a right triangle, 60, 60. So anyone know what this hypotenuse would be? 60 rad 2, right? It's just a 45, 45 then, okay? So you know this is 40, so you can just subtract to find that. Is everyone okay with that? Okay. So the change I would make for part C is, for part C, the person that found it used the correct numbers, and then they put here 86.721. But we know that's not correct. What did the calculator actually find? It found the acute angle, right? So how should we actually get this angle? 180 minus. Okay, so you have to do a little bit of interpretation. Does your answer make sense? Because law of science is a little bit limited. Okay, so the moral of the story is you got to really think, right? So this should be 180 minus. Don't worry, it's just for notes. Okay, this one actually didn't make any sense. Someone pointed it out, but you should just divide it out to be two triangles. The reason why it actually doesn't make sense is because this is a 3, 4, 5. Yeah? But if that's a 3, 4, 5, then this is a 5, 5, 5. So they should all be 60. But they're not. Okay, so let's ignore that for the moment. Let's say you didn't even think about that side. Okay, this triangle is easy. How do I find the area? Let's ask somebody. Kenneth, how would I find that area?
3 times 4 drop it.
Yep. So 1/2 times base times height. That would be that area. How about this area here? How would you find this one? It's assuming you didn't find that diagonal. Okay, Evelyn? Yeah, so what's the formula for the SAS case? 1/2 times? Yeah. Okay, so you would just use that. Okay, so that's the SAS case. Basically, it's the two sides sine of the angle. Okay, similar situation here. You got to kind of think about how to divide it up. Smartest division is probably this one. Okay. So then, talk to me here. Let's start with the easy one. Which one? How would I find this triangle? Yeah, over 2. Okay. How about the other triangle? What would I need to know to find that triangle? Cian, what piece of information would I need to know? Yep, so you can find it from this triangle, right, this triangle. So you can find that the hypotenuse is 13. Once you have the hypotenuse, what would you need to know next? Wendy?
The angle.
Yeah, which angle?
The one between,
I like the way you said it, the one between which one? This one's tricky, so pay attention here. Anyone want to help? The one between which two sides? 14 and 13? That would be the worst one to pick.
is it small?
You should pick the biggest one. You should pick this side, this angle. Okay, I'm not saying it's wrong, I'm just saying it's the safest one to pick is always the biggest angle first. Okay? And then once you have that, you can find this angle as 1/2 13 times 4 times sine or whatever that is. Okay. Everyone okay with that? Any questions? Okay. And then this one, it says assuming angle B is obtuse. Actually, let's skip this. We'll come back to it some other time. Here's what I just want. I looked up our conundrum with, was it this triangle? No, was it?
What's the previous?
It was this one. Yeah? You remember that? Okay. So I made this statement, and actually something Jason said made sense. It said after you use law of cosines, use law of sines to find the smallest angle. That is correct. Let's explain why that is correct. Think about right here. What operation are you going to do right before you get the answer? What's the button you press on the calculator that will give you that answer? Inverse sine. Inverse sine can only give you what two quadrants? First and, so it can never give you what kind of angle? Obtuse. You see that? Law of sines can only give you acute angles, so we're pretty sure the smallest side is going to be opposite an acute angle. Does that make sense? So we know law of sines cannot give us obtuse, so we just pick the angle that we know has to be acute because it's the smallest one. Is that okay? That's the logic there. Alright, everyone seems a little out of it. Pay attention, Max. Okay, any questions? That's for the recording. Okay, so if you've had physics, you know the difference between vectors and scalars, right? So just kind of look at the examples of vectors, look at the examples of scalars, and I want you to contrast them, and I'm going to ask you what the difference is, and then we'll just summarize our thoughts, okay? So look for a moment. Okay, so based on what we said, here's how we'll sort of define them. Vectors are used to define quantities that have both a magnitude, right? As Evelyn said, a size or length. I'll think of it as a length. I'll show you why later. And a direction. Okay, usually given as an angle. Not always. Sometimes it's given as a bearing, like north 20 degrees west, but in most cases an angle. Okay? So vectors are different from scalars, right? Scalars are quantities that are described by a single number. So I don't need to give you direction, I just give you magnitude, a length, a size, okay? So how do we represent vectors from physics? Arrows, yeah. So vectors can typically be represented by arrows. We good? Okay. So, here we go. We're going to take a look at two ways. We're going to look at the visual representation and the component form. Okay, so let's look at this first one. This first one says the wind is pushing on an airplane with a force of 160 newtons pointing north 20 degrees west. So since there's a compass heading, let's put it on an axis. So if you could please draw the axes. This is north. Oh, sorry. We're going west, so I'll point the other way. North is this, and that's west, right? So north 20 degrees west. So north 20 degrees west would be an arrow that looks like this, and the 20 degrees is here. Okay, so please take a moment to sketch that. So that's north 20 degrees west. And the length of that arrow is 160 newtons. Okay? It has a direction and it has a length. So it's a vector. Okay? So component form is if I was to write this vector pointing, or the coordinates of that point that the vector points at. Okay? So take a moment, think about how you would find that x and y component, and then we'll write it down. Okay, so any suggestions? How am I going to find the x and y component of that dot? Okay, Jason, start us off. Oh, okay. So Jason says, let's find this side, which is 70. Okay, then what? Jason, keep going. Okay, so I think, Jason, correct me if I'm wrong, what you're saying is find that, and then what else? Yeah, so what Jason is saying is why don't we go ahead and use Pythagorean, or not Pythagorean, use trigonometry to find those lengths, okay? So here we go. So this is 160, and he used 70, and this is a right angle. Okay, let's find the x component first. What would be the x component of this right triangle? So think for like 5 seconds. Jaden, go ahead.
You do 160 sine 7.
Yep. Sine?
Cosine.
Yeah, it's adjacent, right? Okay. And then how about the height? Daniel?
160 times 910.
Okay. What happens when I pause and look at you like this? I'm waiting for someone to catch the error. What's negative? Yeah, because technically you're going to the left, so this needs to be a negative number. Your calculator will give you a positive number, but technically you have to adjust it to make it a negative number. Okay, the way we write component form is we're going to use in this class these angled brackets. I don't know if you use that in physics. So I'm going to type in 160 cosine 70. For the sake of space, I'm just going to round it to 2 or 1 decimal place. But if you didn't think, you would write 54.7. If you didn't think, but you're thinking, so you know that's a negative. And then I'm going to type in 160 sine of 70, and that comes out to be 150.4. Okay? Cool? Any questions?
Why is it like that?
That's just, that tells me it's not a coordinate, it's a vector. Okay? Where are we assuming the vector starts from? 0, 0. Okay? Any other questions? Alright, take a moment, see if you can figure out this one. This is challenging. See if you can figure it out. Okay, so to declutter that problem, let's just let it be y equal 2x. Okay, what do we need to know? What piece of information is missing in order for us to be able to find component form? Okay, Caitlin, what do I need to know?
Like the angle.
Yeah, this angle. How might we find that angle? And I'll tell you right now, it's not 60. I saw a lot of that. How do we find that angle? Okay, how do we find that? I heard it. Okay, but why? So I heard in. So let me actually not say what was said. Can someone tell me? Can I label the sides of this triangle at all? With what? Up to over 1. Up to, right? That's the slope. Up to over 1. So I can guess, because trig is just a ratio. It doesn't matter if I put 2, 1, 4, 2. It doesn't matter as long as the ratio holds. Go from there. Venus, can you give us the setup of how you find the angle? You don't have to tell us the angle, but what's the setup of how you find the angle? Of? Yeah, inverse tangent of 2 over 1. Okay, that's how you get it. And then if you want to write component form, let's say you know that angle. I don't have space here, so I'll do the work here. Eli, what's the x-coordinate of the position? So what is this dot right here? What's the x-coordinate? Uh-huh. 4. Is it sine though? Yeah, it's cosine because it's the adjacent one. And then the other one is 4 sine theta, whatever that angle is. Okay, are we okay with the component form? Any questions on that? So it's a little tricky because of the slope. You have to use the slope. All right, last one's easier, so just give it a try. Okay, just be sure you're clear on what the picture's saying, right? If this is the horizontal, you threw the baseball at some angle of 45 degrees like this, and your velocity was 62 miles per hour. That's what it looks like visually, right? So how would you find the x component? CN?
62 times cosine of 45.
Yep. And then?
The height is 62 times sine.
Right. Okay, good. So we keep saying height, and that's fine, but I just want to refer to it as the y component. Okay, we all know cosine. Let's do a unit circle quiz. What is the cosine of 45? Wentron? Yeah, very good. Okay, we good? Okay, so here's the notation, just so you're aware. So how do we note there's 3 ways, right? One way is what we've been doing, angled brackets. The other way is actually this, u vector, right? We use that vector symbol, is equal to 3i hat plus minus 5j hat. I'll explain what the I hat and j hat are later, but for now, I just want you to get used to the notation. Okay, that? Or, as a matrix, you no longer learn this in Honors Algebra 2, but as a matrix, you can write it like this, 3, negative 5. This is what's called a matrix, but it's really a vector because there's only 2 numbers, or 1 column, okay? So those are all equivalent. Don't worry so much about the I and the j for now. Don't worry so much about the matrix form, but if it shows up, just feel it. Okay, anyone know from physics what the beginning of the vector is? Maybe you don't know. So we call that the tail. Okay, so here, this is the tail, because it's the end. And then the arrow part is called the tip. Okay. So this is the tip. Just be aware, notation-wise, if I say where's the tip or where's the tail is usually the origin, but not always. And then the tip is just the end. Okay. Any questions on notation? It's pretty dry, okay, but we'll get to a lot of fun physics applications soon. Free body diagram and force and all that. Okay. Is that it? Okay, here we go. Alright, so let's talk about how you would find the magnitude and direction. So I gave you the component form, now I want you to find magnitude and direction. I give you the graph here just for your own sort of benefit. You don't need to use it, but it's just I'm a visual person, so I'm going to use it. Okay. So on the graph, here's what it says. P is -1, -4. So let's graph -1, -4. Let's label it P. And then Q is 4, 5. Q is 4, 5. So let's graph 4, 5. Let's label that Q. Okay. So right now, the way it's written, the tail is at P and the tip is at Q. So that's what it looks like, just kind of the way it's written. Any questions? I said that normally the vector's tail is where? Origin. So what I need you to do is just don't draw this, but pretend it's like at the origin. So the question we're asking is, what is the magnitude? How long is that vector? And second question is, what direction does it go in? So what is the angle of that vector? Pretend it's at the origin, even though it's not at the origin. Okay? So let me give you just a minute or two to see if you can figure it out, and then we'll come back. Okay, my first question is going to be, what is the component form of PQ? Okay, component form of PQ. Ben, what's the x component of vector PQ?
5.
How did you get that, Ben?
Just like drew a right triangle.
So you drew this right triangle, and then?
Just like visualized it.
Let's say you didn't have the picture, but you had the numbers. What would you have done to get that 5?
4 plus 1.
Yeah, you would have subtracted the x values, right? So if you subtract the y values as well, and Kayla, what did you get for the y component? 9, right? You can see 5 minus -4. So there it is. How am I going to find the magnitude from that data now that I know the component? Wendy?
Pythagorean.
Yeah. So I'll give you the notation. I should have given you the notation. The way we indicate magnitude is we draw these double absolute values. Okay? So if you had no way of knowing that, so just put that double absolute value. That just tells me it's a vector, not just a number. Okay, so Wendy said Pythagorean, so I'm going to go square root of 5 squared plus 9 squared. That's 81 plus 25, which is, what is that? I can't do that. Okay, everyone okay with that? So the angle theta I'm looking for is this angle here, which again, if you were to pretend that this is at the origin, is going to be the same as this angle here. Okay, so how would you find that theta? Kenneth?
Inverse tangent.
Of?
9 divided by 5.
Yeah, so everything comes back to writing the component form first, and once you have the component form, then you can find all the missing pieces. Okay. Any questions? Okay, please try B on your own. You can draw if you want, but you don't need to draw if you don't need the visual. Okay, let's start with the component form first. Careful. Evelyn, what's the component form of RS? Good, right? 6 -4. How do you find the magnitude? Again, we're going to use the double absolute value notation. Jason?
5 squared plus
How'd you get it?
6 squared plus
Yep. And you said 5 root 2? Seems reasonable. I don't know. Is it? 36 plus 16? Oh, wait.
6 squared plus
Whatever, right? Okay, I mean, just leave it. Is it 52? Okay, just leave it at that. Okay. How do I get theta? How do I get theta? Daniel?
inverse tangent of -4.
Okay, cool. What was that? Anyone get an answer about? Just give me a clean number. Okay, so I'll say -34. I know usually around 3 decimal places, but it's just kind of hard for me to hear all those numbers sometimes. Okay? That's okay. You can state it like that. So you have to ask yourself, does that look right? Okay? So when you get an angle, you can't just accept the angle. Why can't you just accept the angle? Because domain restrictions for inverse tangent, right? So you have to ask yourself, is this in fact in quadrant 4? Yes. Okay? If you had a vector that actually was pointing to quadrant 3, then that's a whole other issue. So you have to think about your answer. Any questions so far? Yeah, this one's also pointing to quadrant 4, right? 2, 5, 8, 1. So nothing super exciting. Let's get there. Okay? So in general, if I have a vector, AB, right, the magnitude of that vector is just Pythagorean, square root of a squared plus b squared. The direction of that vector, theta, turns out to just be inverse tangent of what over what? Talk to me. A over b? Okay. Okay, plus your brain. Okay, plus your brain. Because you have to ask, is the answer in the correct quadrant? If it's not in the correct quadrant, then figure it out. Okay? Your brain's the most important part of this formula. For some of you, okay, I'm not going to say that because it's going to be on the recording, so I'll leave that out. Any questions? Max, you good? What's next? Okay, try this. And then we probably should stop there. Okay, so give that a try. Okay, this one's pretty straightforward, right? There's P. The vector is in the 2 across -4 direction. So I want to know where Q is. Okay, and again, I'll point out the vector is in the 2, -4 direction. Okay, so 2, -4. So obviously, what is Q, Caitlin? 6, -7. Okay. Any questions? That was an accident.